What is up, everybody? This is Christopher Zeuthen. I'm here to discuss and how to classify matter. Is salad a mixture, or is it a pure substance? Is it homogeneous or heterogeneous mixture? Or is it an element or a compound? What is it? Today, by the end of this discussion, you'll know what it is. I'm going to classify matter in ways that are simple and easy. Let's just dive right into it. Let's go. Okay, so first, what is matter? Well, to just refresh, matter is anything that has mass and takes up space. Okay? That's all you really need to know about what matter, the definition of what matter is. But let's kind of look deeper into more of how you can classify different types of matter. So the most common way of doing this is kind of just making, drawing off branches. So matter can be both classified into a pure substance and a mixture. Well, what's a pure substance? First, let's dive into what a pure substance is. So a pure substance cannot be separated by physical means. So by physical means, it cannot be separated. It has a definite composition throughout. So that means it's got some uniformity to it. So examples of this would be like a salt or a sugar cube. So a sugar cube, all of its atoms, which make up a pure substance and make up matter in itself, are arranged in some sort of orderly arrangement. Same as in salt, those little salt pellets that you dribble on, that you put on your food. Those had the salt itself, NaCl, has some sort of arrangement to it. So when we say that it has a definite composition throughout, we're saying that it has some sense of uniformity, some sense of order to it. But pure substance is kind of the most generic of them all. So it just tells us that it can't be separated by physical means and it has some sort of definite composition to it. But pure substance is kind of the most generic of them all. It's not the most specific. If we want to even get more specific into what a pure substance is, we can break it up into the idea of it being either an element or a compound. So an element, many of you guys know, and compound you do as well, but I'm just going to kind of go over it one more time, just as a kind of little refresher. So an element has only one kind of atom, so one type of atom in it. So for example, potassium. Okay, it only has potassium ions in it. And another cool one, xenon. So xenon only has xenon atoms in it. So if you were thinking of like xenon gas, well, xenon gas would only contain xenon atoms. Pretty self-explanatory. But now if we're getting into what a compound is, so a compound has more than one type. So more than one element present. So it could have two, so more than one element. It could have two, it could have three, it could have four elements. But anyway, a compound has just more than one element present. Okay, so examples of compounds would be like carbon dioxide, water, salt, or even something a little bit more crazy like, say, CH3, CH2. Still only has two elements, but it kind of has a more of a unique name to it. Now we can also talk about what a mixture is now. So a mixture involves pure substances. So a mixture, here, let me kind of draw it down here. A mixture contains pure substances in it. So it's basically those pure substances that we were talking about, elements and compounds, basically mixed together. So one pure substance like NaCl and another like H2O mixed together in one big bundle together. Okay, so mixtures involve two kinds of matter, or they involve the mixture of pure substances themselves. But these pure substances retain their own, so they retain their own composition and properties. So properties are like high melting point, high boiling point, solubility in water, everything like that. And they can be separated by physical means. So what are some physical means to separate them? Well, you could have filtration, you could have decanting. Decanting is pouring off the top layer. Filtration is, when you have like the filter paper. It's kind of like when you're making coffee, how you're pouring the coffee in and then adding water to it. That's kind of how it works. And then you have like distillation, which is the separation of objects who have different boiling and freezing points. So kind of things like that. So they can be just separated by physical means. But just like pure substances, they can be classified into more specific categories. So mixtures can be separated into homogeneous, and heterogeneous. A simple, quick way to remember it is by the pronoun at the beginning, or the beginning of the word homo. Homo means same. So homogeneous mixtures have generally the same composition throughout. It's like the rest. Every part of this is kind of like the rest, and it's evenly distributed. And when you have something that is a homogeneous mixture, you will often call it a solution, too. But the opposite of a homogeneous mixture, in turn, would be a heterogeneous mixture. So its composition and properties, though, in a heterogeneous mixture, they vary from point to point. Vary from point to point. Vary from point to point throughout the solution. So it's not really uniform throughout. And I think the best way to differentiate between a homogeneous and a heterogeneous mixture is through examples. So let's go through a few of those. Okay, let's look at something that we mentioned at the beginning of the video. Salad. Let's think about this. Is it a homogeneous mixture or is it a heterogeneous mixture? We know that salad itself is not an element, and we know it's not a compound. So it has to be a homogeneous or heterogeneous. Let's think about this. A homogeneous mixture has, generally a uniform composition throughout. Does salad? I don't think so. You've got, chicken here, part of it, avocado here, tomatoes, corn, all that, all different textures and made of all different things and have all different sizes and shapes like that. So there's a sense of discontinuity, a sense of non-uniform to it. So in a sense, I believe that this would be a heterogeneous mixture. It really doesn't have a general uniformity to it. It's kind of all over the place. Pieces of food of all different sizes to it. Let's try another example. Now, what about sand? Is it homogeneous or heterogeneous? Remember, heterogeneous mixtures are composed of particles, that vary in size, shape, or phase. Well, sand is composed of quartz. So sand is quartz, okay? Sand equals quartz. But sand has some other things thrown into it. If we're talking about beach sand, in this case, I am. So sand would also be heterogeneous as well. The reason being is because sand, the sand particles, even though we really can't see them, and you would think it's uniform, you think, oh, every little piece of sand is the same. It really isn't, because sand is composed of a bunch of different particles, bunch of different minerals. So just know that there's a lot. You probably don't want. Just remember, sand heterogeneous. I'm gonna write that really big here. Sand is equal to heterogeneous. So when that's on the test, because I am wink wink pretty sure that it is, sand equals heterogeneous. Heterogeneous. Okay? Let's go on to our next example. Now, let's identify if it's a homogeneous or heterogeneous mixture. If I were to take my salt here, and I were to put it into this water here. Well, before going into that and determining if it's homogeneous or heterogeneous, let's just see if you remember a little bit about pure substances. What's salt? Well, salt has sodium atoms, and it has chlorine atoms. So it's got two different elements to it. It's not a mixture because it's not combining two pure substances. So salt is a compound, and water, as all of you know, is H2O. It's got hydrogens and oxygens. So, would H2O be a compound or an element? Well, it's combined. It's made of two elements, so in this case it would have to be another compound. So when we put salt and water, so we can just kind of picture this, all these little salts here. Bloop, 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 bloop. Would it have a uniform composition throughout? Well, let's just think of this. Picture yourself at home with a nice glass of water, and you put some salt in it. You stir it around. Does it mix fully through? I think it does. So it mixes fully through. The salt particles don't really vary in size, and it can dissolve fully in it. Then I think it would have to be a homogeneous mixture. Sweet. That's all I got for you. This is Christopher Zeuthen signing out. Let's go.